Okay, well, hello. This is a meeting about continuous integration and continuous deployment with Amazon Web Services. So, first of all, a couple of disclaimers. This is not a crash course into DevOps. I'm not a DevOps by all means. I mean, I'm a dilettante. So everything said here, take it as is, right? And this is very Amazon Web Services specific. This is whatever we talk in here is not easy transferable to any other cloud platform out there. So what is the rationale of this? In the past, doing automation in Amazon Web Services required additional tools. I mean, other stuff being run whether on a third-party service or inside Amazon Web Service, but things that you had to configure yourself. So let's dig into it. Okay, CI what? Continuous integration, what is this? It's a deployment practice that requires developers to integrate code into a shared repository several times a day. Each check-in is then verified by an automated build, allowing teams to detect problems early. By integrating regularly, you can detect errors quickly and locate them easily. This is a practice that started happening like maybe 10 or 12 years ago. And the idea is that you integrate your development into some sort of collector for that deployment, for that development as often as possible. And the idea is to catch early any integration issue, you know, these kind of pesky bugs that happen. Maybe you don't see it on your development branch, another branch being developed by another developer doesn't have issue, you put the two changes together and they cause a bug, an integration bug. In this way, you catch this type of problem early. What about continuous delivery? Continuous deployment or continuous delivery is a software engineering approach in which software functionalities are delivered frequently through automated deployments. Continuous deployment contrasts with continuous delivery, a similar approach in which software functionalities are also frequently delivered and deemed to be potentially capable of being deployed, but actually not being deployed. So basically the idea is that anything you develop is actually delivered somewhere, right? It's not just in your local. So it works on my machine, doesn't count anymore, right? Questions so far? Okay.
Nope.
So,
no questions.
Options. There are plenty of tools. As I said, this practice started happening many years ago, and there are plenty of tools to do this. We have Jenkins, CodeShip, TeamCity, Hudson, Travis CI, Drone, you name it. I mean, there is a lot. So which one is best? Every tool has its own pros and cons. I'd say the best tool is the one that requires less work to be configured and to get it working. So some time ago, Amazon Web Service launched these developer tools. What is this? They are tools to host code. This is like in repositories, right? And also tools to automatically build, test, and deploy applications. So they kind of roll out their own version of these automation tools. It's a set of services, according to their documentation, it's a set of services designed to enable developers and IT operation professionals practicing DevOps to rapidly and safely deliver software together. This service helps you securely store and version control your application, source code, and automatically build, test, and deploy your application to Amazon Web Service or your on-premise environment. What are the pros of using Amazon Web Services' own developer tools? It's free, quote unquote, right? I'm going to come back to this. Everything is in one place. This is, if you are using Amazon Web Services for your infrastructure, you also have your automation tools in the same platform, and you don't have to take care of paying extra fees to a third-party service or anything like that. It integrates seamlessly with the rest of your infrastructure. Anything that you can catch with CloudWatch, you can use it on the Amazon Web Service developer tools. For example, you can use also Lambda functions to trigger or react based on CloudWatch events. And you also have the fine granularity of configuration of IAM to kind of, for example, allow commits between certain times or from certain geographic zones, right? You have really, really granular control about the permissions of the users into repository. And you forget about setups and scaling. Back in the days, if you wanted to have some sort of automation for your deployments, you needed to kind of install your own instance of, let's say, Jenkins or something like, or Hudson, something like that. You forget about this. Everything is taken care by Amazon Web Services. So as George Gurdjieff said, there is only one kind of magic, and this is doing. So let's do some automation right now. So I'm going to show you how you can set up your own code pipeline in Amazon. So let's go here. CodeStar is the name of the like the landing page of their development services. I have already in place a project that I made just a couple of hours ago. And I will show you how it looks, and then we are going to build our own. So here is a dashboard in which you see the application endpoints. This is whatever is accessible in the application. This is a web service or a dashboard or some sort of web application that is accessible through HTTP to the end users. You have the continuous deployment dashboard here in which you see the current state and some application metrics, right? So basically, when you set up a project, you configure Git repository. It can be GitHub or their own version of GitHub, which is called code commit. And then any push done to this repository will trigger a new build. And if the build succeeds on the pipeline, it will deploy the application in the instance that you configure. And I'm going to show you right now the application itself, what we have here, right? So it's a very, very simple Express application. It has just 2 endpoints here. So basically, there are just 2 endpoints, as I said, the root endpoint, which only exposes the public directory here, and an echo endpoint that is a post endpoint, and it will send you a response with whatever you put in the request body. Let me show you that. Okay. So let me see. Oops. I'm going to just show you how does this look.
What is it? What is this file for?
No, this is just a tool to do requests. I mean, whatever you can do with curl, you can do it with this tool. Basically, you write requests as code. So I'm going to send to, I'm going to post to localhost 3000 this request, right?
Do you feel this tool easily to work than Postman, for example?
Yeah, because it's code. I don't need to click anything.
Okay.
And this is what? Oh, sorry. I have another thing running in here. Another 3000. Okay. Now we can go. I mean, you can use Postman as well, but I rather write than clicking. I know, just a matter of personal preference.
And how do you run that?
This is from JetBrains. Oh, and if I put the endpoint here, there we go. So see, I send foo one. Oops.
Yeah. It's with a J at the end. FYI.
Okay, this is my clever application, right? Okay, so this is what is delivered, is already deployed in this application, and I'm going to show you this. This is our endpoint. See, this is the public directory, this one, right? And we are going to kind of hit the same endpoint on here. See, exactly the same application. So we are hitting the production instance right here. I have a couple of tests here. I have integration tests and some sort of unit test, quote unquote, again. And this is passing, right? So here I'm going to make the test fail, right? On purpose. So it fails, right? And I'm going to commit a failing test, okay? and I'm going to push it to the repo. So if we come over here, you will notice, is it push already? This is how their repository looks, right? But here, it just caught the push and is kind of executing all the webhooks and all that in the repository itself. Then it's going to go to the build process. I'm going to come back later on how do you configure what happens in this step. And then if the build succeeds, in the build you do anything like running tests and all that. If this succeeds, it will deploy to any instance or any environment that you have for deploying that particular application. And right now it's building. You can always come and see the logs running. What is the big advantage of this? If you use a third-party service, this happens somewhere else, right? In another service, the CodeShip, Circle CI, or whatever you are using, and the integration is always painful. See here, it's entering in on the pre-build phase, running npm test, and it failed, right? So as it failed, let's refresh here. As it failed, it didn't deploy. This deploy, the current one, is the previous version. It won't happen again. If there is some intermittent issue or some bug that is happening from time to time, you can always retry. We know that it's not going to succeed, right? And so let's fix the test and let's change something. Let's see. So here I'm doing, I'm sending the same body, right? Let's, I don't know, what can we do here? You, me, hi. And we are going to make also this test pass. So this is going to be you. Me, hi. I'm just changing the response, right? Let's run it again. Oops, what happened?
I think the high was with capital.
Oh, sorry.
No.
Yep.
Not sure.
Expected here.
Oh, there it is.
What did we get? Oh, no. Hold on one sec. There we go. Oof. Oh, that's okay. I mean, we know we are using port 3000, but the tests are passing. If I kind of break, it should pass. Okay. So I'm going to deploy the new change.
So lovely.
Yeah, I know.
You're romantic. You're romantic.
Yeah, all my fan club always say. Okay, so it should come here in any time. In the meantime, while we wait that everything happens automatically here, I'm going to show you exactly how do you configure these steps. Whenever you create one of these projects, you must put a file called buildspec.yaml. YAML, if you don't know it, is a format is similar to JSON, but it comes from the Python world. It's also very used in Ruby. So Amazon Web Services uses YAML to configure the build process itself, which is composed of phases. You have an install phase, a pre-build phase, a post-build phase. You can configure artifacts of the build process. We don't have any build step right now, but you can add it here. And I can show you right now in the pre-build, it runs the NPM test. If that breaks, it won't go to the next step. Then in the post-build, it will remove the node modules, then install the node modules, but as it was in production, right? Then it's going to do the cloud formation steps to kind of deliver all the infrastructure. And this is a command used to tell your instance that this is the new environment in which this application runs. So let me see. Okay, as you see, the build succeed, and right now is deploying. When it finishes deploying, we should be able to see the new response that we just made. We can always see the logs for this. See here. It kind of takes some time because it has to spin up a new server from scratch. It uses images, but it creates the elastic load balancer and all that between the scenes. So while we wait, let's do this because this can take some time. While we wait, I'm going to show you how you set up a new CodeStar project. So when you create a new project, you have a lot of templates to choose from, like really a lot. So what I did for this particular one, I created an Express.js application and I used an Amazon Web Service Elastic Beanstalk for the configuration, because since it was so simple, I wanted Amazon to kind of handle everything. If you don't know Elastic Beanstalk, what it does, it is to create like a full EC2 instance and then create the Elastic load balancer and do all the configuration to expose a server on that particular EC2 instance automatically. So Amazon Web Service takes care of everything. So you choose over here, you put a name. Here you can choose if you want to use GitHub or code commit. The advantage of code commit is that it gives you much more control of who and when deploys code. And then you just create the project, right? You need to, there are some configurations here. You need to set up a key pair to kind of access the EC2 instance if you want to do it by hand. Here you choose how to integrate. I usually just use command line because you can use it anywhere. And what it does, it creates the repository for you. Okay.
Is this free?
Regarding the pricing, yeah, it is free in the sense that the automation itself doesn't cost anything. Amazon gives you that free. What it will charge is for any resource used in the automation. So let's say if your automation pipeline requires to deploy a database, it will charge you for the database. If you deploy an EC2 instance, it will charge you for the use of that EC2 instance. The automation, the code pipeline itself is free.
Yeah, but what I mean is you create a new instance to use, let's say that you want to test something, for example, what you're doing right now. And
yeah.
Are they going to charge you anything for that, or they have like
No, I told Nacho that you were going to pay for the expenses of the talk.
Okay.
No, I'm just kidding. Probably for this particular test that we are doing, they are going to charge something like 20 cents or 20 or 30 cents, something like that.
Okay. I thought there was some sort of minimum amount of storage limit or time to use, so you will get charged.
It's super cheap, and if you want to kind of train, they have a free tier, and you can use, I think, within certain constraints, you can use whatever you want for 1 year, like a maximum amount of requests per day or something like that. This way, they kind of encourage the developers to learn the platform.
That's good.
So if everything went well, okay, this is deployed. So if I hit the endpoint, this endpoint, no, not this one. See, this is the change that we did. And you don't need to do any manual deployment process. It just happens as you push or merge into a certain branch. One more thing that I wanted to show you, when I created this repository, kind of to illustrate all the things that you can do, I created a Lambda function that basically sends Slack messages to this channel. And whenever pipeline changes its status, it will send you a message with the details here. Let me show you that. If you do that with a third-party services, chances are big that this is that something like that will be a pain. Kind of having something to happen after you integrate in a third-party service. That is the typical painful thing when you use a third-party service. So let me show you here. There is this Lambda function called Slack message. It's super simple. Basically what it does is to build this message. Basically it's a JSON string, and it posts to this endpoint, which is our Slack webhooks endpoint. Basically, whatever happens, it will come formatted over here. And how do we trigger this? We use the CloudWatch event. See, whenever, this is the rule that I set up. Whenever code pipeline event happens, just call the Lambda function, sorry. Basically what you do is here, service, you can put whatever you want in here. See, for example, code build, then add a target, and you select a Lambda function, and then you can do whatever you want, right? See, from sending a Slack message to automating anything else you want in other services and all that. So basically, this will be it. That is the gist of using the Amazon Web Services developer tools. And this is very easily to allow you automating a process that otherwise will be tedious and will require a person to kind of take care of all the infrastructure and all that. So let's just quickly come back to see if this is already set up. Okay, this. And basically, it just grabbed the base commit and right now is deploying it. So what you do basically is to kind of clone the Git repo. You will need someone in the someone with administrative access to allow you permissions, to grant you permissions to kind of clone that repo. And then you will do anything you do usually with any Git repo. I mean, the process is exactly the same. So I don't know, guys, do you have any question? Do you want me to do something with this?
No question.
Yeah. Well, I do have one question.
Yeah.
Why did you choose AWS to do continuous integration instead of Jenkins, for example, which is, I don't know, at least on the claim that I'm working on, it's the most used tool to do continuous integration?
I'm not a big fan. Personally, I'm not a big fan of Amazon Web Services, but it's what White Prompt uses for a lot of clients and company projects. Actually, the White Prompt's website is made with a Ruby static site generator. And I discovered these tools while trying to automate this. We had this made in Ruby. Nacho told me, I want this to be automatic. do whatever you need to. And I started digging, discovered this new stuff. Okay, we are already using Amazon for this project. Let's do everything in Amazon. Again, I'm not personally not a big fan of Amazon Web Service. I'm not against it either, but I've had hard times with AWS in the past. Sorry, which service did you mention?
Jenkins.
I don't know. How do you write that?
What do you mean? How do I write it?
What's the name?
Jenkins.
Oh, you mean Jenkins. Oh, the problem with Jenkins, and this is what AWS, for Jenkins, you need to say, okay, I need a machine. I need to install Jenkins. I need to maintain it. I need to make 100% sure that that particular machine running Jenkins is up to date, that I need to install the plugins for the particular deployment or the particular automation that I need to do. With an with an automation tool, you forget about that. You don't need to maintain anything.
Okay, that's good. So basically, if you have a DevOps team which actually knows about Jenkins, maybe it's a good tool to use. But if not, AWS, it's another best option. Okay, and then sorry.
Yeah, go ahead.
The second question is: let's say that you gotta deploy to staging and production. You have two environments. I mean, not two environments. Yeah, basically staging and production. And for them, you use Devil as for staging, and then you use Master for production. How do you set that up? So when you deploy, you push into Devil, it will run.
Right, like having two different environments.
Set up. Yeah.
Exactly. You will do that on the build spec YAML. So basically, what you will do over here. Hold on a second. Nope, not this one. What you will do over here is to have two different Elastic Beanstalks, and you can choose to do it in two different ways. One is two different code pipelines, and you will configure the particular branches for one code repository, or you could have two different code pipelines, which wouldn't be a problem. But basically, you will need two different Elastic Beanstalks if you are using that particular solution, right? So let me check that. So basically, in the cloud formation for that particular Elastic Beanstalk, you will need to do some sort of matching between the name of the events, right? Let's say for the branch, if you say whatever the event is that matches this branching name, then do this. That will be the way to do it. Personally, haven't done it in AWS, but it's a good exercise. Maybe we can investigate about that.
Yeah, what we do on Jenkins, we create the Jenkins files. We establish what will happen on the build, how will happen on deployment, etc. And then we can have a sort of checking for the name of the branch that we just push. and then it will run different kind of things depending on if it's staging, if it's production, and well, I just wanted to see like if it's similar here.
You know, one thing that I wanted to do, I was short on time, but one thing that I would love to kind of see if it's possible if you use Heroku, they have this feature to do continuous integration, in which whenever you do a pull request for the application, automatically Heroku will create a full instance for that particular pull request. So any QA done for that particular pull request is totally isolated from any other code in the application. So the QA team only is going to test what is supposed to be testing. You won't have like regressions because of some other feature. So this application is deployed and you have a full instance just for that particular pull request. And whenever that pull request is merged, that particular instance dies, is killed. Not sure how to do that, something like that on AWS, but I think it's a good exercise because it's really useful to have like separate instances in order to test very, very particular pull requests.
Yeah, I agree on that.
Okay, so takeaways from this. I think this is kind of new. I think they launched it in October 18, I guess. And it's fairly new. It still is very, very new. There are, for example, certain very, very stupid things. When I just cloned the Git repo for the project that I just showed to you, there wasn't a Git ignore, and actually I was cloning the complete node modules folder. It was in the repo, right? So when I was pushing code and I was trying to run the tests, I had a permissions issue on Mocha. I didn't have permissions to run Mocha. And I realized that it was for the node modules being in the repo itself. So the technology is still new. The solution is new. With time, I'm pretty sure it's going to get better. My key takeaway of this new service that they offer is that they are aiming to have everything happening inside their platform, which is good and bad at the same time. You lose diversity, and you lose like the fresh air and the new things that you find when you go outside. The good news is that everything happens within AWS, and you can use CloudWatch to do virtually anything it's possible to do. So I think this is going to change a lot and quickly this year. So that's what I have for you guys. I don't know.
Does anybody have any other question for Fabricio?
No questions.
Okay, all right. I'm going to go back to the mine, guys. Thanks a lot, and I will edit the video and upload it probably later today.
Okay, thank you very much. You were very clear.
Thank you.
Fabi.
Bye-bye.